Hello my friends, this is Noah and welcome back to the channel. Those of you who love meta-analysis, I have great news for you. We're going to do a meta-analysis today and we are going to do it in JASP. So JASP has just gotten this freaking awesome update and it now has all sorts of really cool types of meta-analysis. So I am not going to totally nerd out on all the different JASP things in this video. I'm going to do my best to stay focused on a conventional meta-analysis. So with this, we're going to do a conventional meta-analysis in JASP. I'm going to show you how to do it step by step. The dataset will be linked for you in the description. This is a dataset we use a lot in the R tutorials. So we're going to see, one thing I want to mention real quick, we're going to see a little bit different overall effect size. That's because in the R tutorials, we're using the Z distribution, and in this, we're going to use the KNNH distribution. So I'll talk a little bit more about that as we go. Just know that if there's a little bit of difference in some of the numbers, that's why. So let's check it out. So this is JASP. We opened it up. I'll include a link in the description for those of you on Mac and PC. And if you're on Linux, I am on Pop! OS, and JASP is available as a flat pack in the Pop! Shop. So let's go ahead and get started. The first thing that we are going to do is upload our data set. So I'm going to do that now. All right, here is our wonderful data set. I will make this full screen. All right, so as you can see, we have our studies over here. We have a fake variable. This is continuous, just so that I can show you guys how to do that. We have grade range, which is a categorical variable. Same with country and study setting. Then we have the mean standard deviation sample size of our groups. So here's the thing. We can't do a meta-analysis yet because we actually need to compute the effect sizes first. So JASP will help us do that. So over here on the right-hand side, I'm going to click on this little plus, and I turned on meta-analysis. So if you don't have the meta-analysis in the top bar, like you can see for me, I have it here on the top bar. It's because I turned it on already over here. But if you don't see that, which I didn't see it when I first fired it up, all you got to do is go over here and click that button. That'll make it appear. So I go here and I go to effect size computation. Then I'm going to use independent groups, quantitative, and standardized mean difference. And so then I just start filling in these blocks, right? So it asks for the experimental mean. That is my group 1. Then I'm going to drop standard deviation into standard deviation for group 1 and sample size into the corresponding one. Then I'm going to do the same thing for the control groups. All right, and that's all I need to do. And you can see over here, it computed 27 effect sizes for my meta-analysis. There's a bunch of other options down here. The computed column names, it's just going to be called effect size, standard error, and effect size type. Not worried about that for now. That's going to be good enough for me. So I'm going to go ahead and I'm going to click the X to close that. Now you can see in my data set, bam, we have our effect sizes and we're ready to do a meta-analysis. So let's get cracking. This is so easy, guys. You're going to love this. And it's free. I cannot believe this is free. Okay, so here you can, oh my gosh, I'm so excited. Look, I just got to mention it. Meta-analytic SEM, SEM-based meta-analysis. These weren't there before. I'm so excited about those. I don't know enough about that, so like I'm not going to have a tutorial on that soon, but that's always something I've wanted to do. So at some point, probably in the future, I'm going to dive into this because I can't believe they made a GUI for it. I'm so excited. Okay, anyway, focus, Noah, focus. Let's go to the meta-analysis module under classical meta-analysis. So what do we see? We see this nice little box here. First thing it wants is our effect size. All we're gonna do is move that over. Then it wants our standard error. We're gonna move that over. We're gonna keep it on REML. Don't change that unless you have a reason to change that. Like if you're doing a meta-analysis where you know I shouldn't use REML, I should use something else, then change it. But if you're new, REML is really popular, so I'm going to say we're going to stick with REML. For fixed effect size, you can see here we have a number of options. Okay, we got Z, T, KNHA. Now, in a lot of my tutorials, I use Z because that's what the default is in Metaphor, if I remember correctly. In this case, we're actually going to use KNHA, and it is because it gives us a, I guess you could say, it's a recommended method. Right now, we're going to leave the rest of these, so we're going to leave it blank for predictors. That's what we're going to use for our moderators, but we're not going to do that yet. Clustering, again, we're going to leave that blank for now. Study labels, we do need to do this. So we're going to take study author, and we're going to put that there under study labels, and we're not going to do anything for subgroup right now. So what do we see already? Pretty cool stuff. So pretty cool stuff is what we're seeing already. So the first thing that I'm going to do, I'm going to go down here to advanced, and I'm going to click show metaphor R code. There's two reasons for this. One is so that you understand what's happening behind the scenes because JASP is based on R. And two, because I find it to be an easy way to confirm some of the things that we think are happening. So when we're looking, we have our heterogeneity estimate. This is Q. We can see that this is significant. So we do have significant heterogeneity. Then when we look at our pooled effect size down here, we can see it is 0.614. So that's our overall effect size for a meta-analysis is 0.61. We have the 95% confidence interval. And if we go back up here for pooled effect, we can see that this is statistically significant. So let's keep going. The tau and tau squared are also provided for us here so that we have them. Now you may be wondering, well, what about I squared? What about all these other things? We're getting there. Okay, let's go check this out. So I'm going to show you under model. We're not going to use this step yet. Okay, we're going to come back to the model tab. We're going to go instead to statistics. Now what I'm going to do is I'm just going to click I squared. Bam, now we have our I squared statistic. We can see it's 73.51%. So we have some significant heterogeneity here as told us by the Q test, and we have a pretty high amount judging by how I squared is 73. So I'm not going to go on to our moderator analyses yet. We have all the basic information we need here for our overall meta-analysis. So let's continue, okay? What do we want next? A lot of times we want a force plot next. So I'm going to click on the force plot tab, and I'm going to click on study information. And now we can see this is the default that comes up. This is informative, but it's not too informative. So the first thing that we want to do is move this study author column to selected variables. Now we have this here, and this is much closer to what we're used to seeing. So for the title, do we want it called study author? I think I'm going to call it that. I'm just going to say, okay, I'm going to click off of it, and it should appear here momentarily. There it is. Okay, so you can see we have a bunch of other options. I'm not going to go into these other options right now because I'm just trying to do a very basic meta-analysis, and I'm assuming that if you know about some of these things, then you probably don't need me to go through them right now because they're check marks. So let's continue. Model information. So one of the things that I'm going to show you something that some people like, some people don't. Okay, and that's the overall effect size in the actual force plot. So if we want that, we just click on model information. We can turn on or off any of these things. So as you can see, it came up here with the heterogeneity and the pooled effect. I'm just going to turn off tau, and I'm going to turn off the pooled effect estimate test, and I'm going to turn off the heterogeneity test. And so I missed the checkbox. There we go. Okay, so now we have our pooled effect estimate down here of 0.61. So, one thing that I forgot to mention, all of these things over here on the right, they're really easy to export. All you got to do is click on that little button and you can save the image. And then you can copy paste it into a Word document or Google Doc or whatever it is that you want to do. So let's continue. We have our overall effect size and we have our force plot. You probably also want a funnel plot. So we're going to go to diagnostics, and we are going to go over here to the right hand side and click on residual funnel. Boom. Now we have our funnel plot right here. So that's pretty much it. That was so easy, wasn't it? We went through and we got our overall effect size. We got all of our statistics for it. We built our two plots. So what do we want to do next? Why don't we look at a moderator analysis? Okay. So what I'm going to do is I'm just going to collapse the force plot, and I'm going to collapse the funnel plot to get that a little bit out of the way. And then I'm also going to go up here to the very top, and let's look at country as our predictor. Okay, so what this is going to do is, let me just minimize a few of these real quick. Okay, so now we have country as our predictor. So that has changed our overall pooled effect, right? Because right now, basically what we're doing is meta regression. But what we're wondering probably is, let me open up this model tab. So you can see here, what we have is we are using the component of country in our model, and we are including the intercept. Now this is reflected over here on the right hand side. Now some things that you're probably wondering if you've watched the other videos. The test for moderators, easiest way to look at it is up here at the top. Okay, so meta-analytic test, you can see we have our test for moderation. It's giving us an F value instead of a Q value. It's doing that because we used the KNHA method. If we had used the Z, it would have been Q. But since we used KNHA, instead we are going to see it as an F with 2 degrees of freedom. And when I say 2 degrees of freedom, I mean 2 degrees of freedom terms, and as well as the statistic test and the P test. So I can see that this is not statistically significant. Now, in my field, we don't typically report the table like this. Like you can see that we have intercept in this table. That's not how we would do it in my field. Instead, what we would do is we go over here on the right-hand side and we would click that button to get rid of the intercept. And this is the table that we would report because now all of them are there with our estimates and the rest of our statistics. Now, something that is incredibly important. Up here, it now shows the moderation test and it's different. This is a different test. This is a different test, okay? This is not telling us if there's differences between the levels. This particular test, without the intercept, is telling us if any of them are statistically different than 0. That is different. That is fundamentally different. So in my field, what we are going to do is we are going to leave the intercept in to get that test for moderators. Okay, this is telling us if there's differences between levels of the moderator. That's the one that we really care about in my field. So I'm going to grab that, and then for my table, I'm going to turn that off, and I'm going to use this particular table. So the last thing that you might be wondering about is, what if I want to do a, let's say like a meta regression with a continuous variable? So what I'm going to do is I'm going to move country out of our model terms. I'm going to go up here to cont, or continuous. I think this is properly labeled as a continuous variable in my data set, but I just want to make sure here. Okay, so we have continuous here, and we're going to move this over, and I'm going to take the, I'm going to take country and grade range out as predictors. So now I just have my continuous variable. I'm going to include my intercept in the model. And now what we can see is, number one, first and foremost, we can see that this is not a statistically significant moderator. And considering I just made up the numbers for this is not surprising at all. But this is that, and then this would be the table that we want to use if we were doing like a standard meta regression and we wanted to report the intercept and all that. Now, the last piece is the R code, right? So down here, you can see the R code. Now, what if we remove that intercept? How does that R code change? See how it adds in that -1? That's the difference that we see here. It's a very, very small change in code, but if you need to provide the R code, or you want to provide the R code for reviewers, then you can do that. It's so easy. You can just copy this code right here. And the other piece that I like is we can make sure we understand what's happening in R, because after all, everything here is made by humans, right? Like JASP is made by humans who are creating this beautiful interface for us to work with. And so that way we don't have to do all this coding. So you can see and make sure that exactly what you think should be happening is actually happening. So the one last piece of advice that I'm going to leave you with today is to ensure that your variables are the type of variable that you expect them to be, either nominal or ordinal, okay? So that will make a difference, and you want to make sure that they are correctly set up. Oh, so there is one more thing that I forgot to mention as we were going through. So with our overall meta-analysis, we forgot to check and see if there are any influential. So let me pull this back to our original overall meta-analysis, okay? So here we are at our overall meta-analysis. It's still updating. Okay, we have our overall meta-analysis, we have our test, we have our overall pooled effect, etc. Now, something that I typically do before I even go on to a moderator analysis is check for influential studies. Now, you can do this quite easily. All you got to do is go into the diagnostics tab, then go to case-wise, turn that on. And what that's going to do is it's going to give you the statistics down here for all sorts of really fun things. But in a standard meta-analysis, all we got to do is look over here on the right hand side, and it's got this influential column, and if it says yes, then you know that something in here is significant. So then we could go back and we could examine the study, see if maybe there's a data entry error, if there's something going on with that, and figure out what it is that you're going to do with that study. Okay guys, so I'm recording this on a different day, so I apologize if the audio is a little bit different, but I realized I totally forgot to talk about publication bias in the previous video. I'd gotten influence in there, and I'd totally forgotten about publication bias. So why don't we go look at how we create a funnel plot and run some of these publication bias tests. So what we'll do, go up here to meta-analysis, and then we will go to funnel plot. So here, we just simply plug in our effect size, we plug in our standard error, and then if we want to, we can include our study labels, but I don't think I want to do that here. I'll do it just to show you what it does. But in this case, there's just too many of them kind of clustered up and in the way, and I don't particularly want to do that. So I'm going to leave it more like this, which is how I would normally have it, see it reported in my field anyway. Now, here's something that I want to point out, okay? So when we are looking at this, this is with the overall effect size being 0, right? If we look at where this is, basically the center of our funnel is right at 0. Now, a lot of times that's not how we would report it in my field. Instead, we would be doing what in here it's referred to as the alternate hypothesis, but it's what our overall effect size of the meta-analysis is. So I'm just going to check that, and then I'm going to turn off the first one to make it a little bit more clear. Okay, so now that we're looking here, let's change up our colors a little bit. I'll turn on fill colors because I kind of liked that. It was a little easier for my eyes to see it this way personally. And when we are looking at this, what do we see now when we look at the symmetry of it? Well, it looks reasonably symmetrical to me. I don't see anything too crazy. You know, we got this one study out here, and down here we're missing a little bit, but it's nothing too crazy in this case. So here's what we'll do. What we'll do is we will go ahead and move on to our publication bias tests. Now, the first one that I'm going to mention is asymmetry, which we were just talking about. So I'm going to turn off this meta regression and I'm going to turn on this Eggers test, because Eggers test is what we usually see in my field being reported if we're looking at a statistical test for funnel plot asymmetry. Sometimes we also see Begg's test, but Eggers test is more common in my field. So when we are looking, what we are looking at here is this first, well, I should say this second one, because it is the one for the weighted regression, just like it says here, weighted regression, over here, weighted regression. So when we're looking at the results from Eggers test, what do we see? We see a non-significant result, which means that we do not have statistically significant asymmetry according to that particular test. Now, next we can do a trim and fill. I really like trim and fill, but I don't really have a good statistical reason for liking trim and fill. It's just one of those things that it gives me an understanding of my data that I find useful. So what I'm going to do is I'm going to actually turn on well, first thing I want to point out is it brought up this funnel down here, right? And you can see that it has imputed 2 studies over here on the right-hand side. These are these hollow ones. These are what trim and fill has imputed because it feels they are missing. But I like to turn on the estimates table, because it just makes it a little bit easier for my brain to wrap its mind around. So down here, you can see that we have 2 studies that we estimated were missing. And if we impute them, it moves our effect size to 0.677, or what would be rounded to 0.68. So I like that feature. I'm not saying this is a particularly good or bad test. It's just one that I have always liked because it gives me some numbers, and my brain likes to latch on to numbers like that, and it also helps me visualize where these studies might be missing from. So a bunch of options here as well. I'm not going to go over them right now because I think for most people, this is what you'd probably end up doing is imputing those studies and looking at how the effect size changes, and then also looking at where those studies were specifically imputed at. Now, next, let's move on to the failsafe N. So I'm going to turn those on. We'll give this a second to update here. Okay, and we can see the first one has come up down here at the bottom. I'm also going to turn on Orwin and Rosenberg so that you can see how those get generated and what they look like here. Now, I'm not going to comment on the failsafe N's because there's a lot of, well, the reality of this is my personal belief right now is that you shouldn't take any one of these individual tests as being like, oh, this means there's massive publication bias, right? That's not the way I like to interpret these publication bias tests or sensitivity analyses. Instead, I like to think about these as helping me understand the context of my meta-analysis. So for example, when I look at the trim and fill, I can see that we may have missed 2 studies over here on the right-hand side, or they are at least missing from our analysis. So if those were imputed, how does that actually change our overall effect? And is that something that has some sort of massive significance for our actual analysis itself? So we can do a quick comparison, just using that as our comparison point, just to get started, because I don't want this video to be just about interpreting publication bias tests. But let's say this is 0.677 is what it would be if those 2 missing estimates were there. Well, let's go back to our classical meta-analysis and see what our overall effect size was. Our overall effect size was 0.61. So the question that we'd be asking ourselves right now as meta-analysts is, first and foremost, is there a huge difference or a notable difference between an effect size of 0.61 and 0.68? In my field, that's not a huge difference. I mean, it's notable, but it's not necessarily going to change your everyday practice, because overall, the difference between a 0.61 and a 0.67, it's not that huge of an effect size difference, right? So what do we say from this? What do I interpret? The way that I would probably interpret these findings is I would look down here. I would say my funnel plot is reasonably symmetrical. Our test for asymmetry showed that there was no significant asymmetry. However, our trim and fill analysis found that there were 2 studies missing, which would change our overall estimate to 0.68 if they were included. So while there may be some indication of publication bias due to missing studies, overall, we don't expect it to have a hugely overbearing influence on our overall meta-analytic effect size. So I would say something along those lines. So that said, I realize I've already talked longer now about publication bias than I need to. The reality of this is JASP lets you calculate all of these things very, very, very quickly, just like you saw. So as I think I've probably said in a number of other videos, I really think that JASP is probably the most approachable, in my personal opinion, one of the most approachable ways to do meta-analysis, especially now that there are so many more modules in here. I mean, look at all these different types of meta-analysis you can do. And it's point and click, and it's free. JASP is free. Okay, so I don't know. I am super thankful to the JASP team. I need to also acknowledge that the meta-analysis module that we're using right here is based on the metaphor package to R, to my understanding. So thank you to the developer of the meta-analysis package for R of metaphor. That's Wolfgang. Thank you to you. Thank you to all the folks who have worked on JASP and made this wonderful thing publicly available. The guys who have replied to me on GitHub about some of the issues I found in the previous version of JASP, thank you so much for understanding what I was saying and then quickly fixing it. Like, that is awesome. I am so thankful to everyone who's working on these R packages and working on JASP to make it so we can all do really fun statistics. And not only that, we can do it for free. So that said, I'm going to stop talking here. Thank you guys. If this video has been helpful for you, please like and subscribe to get more meta-analysis information from the channel. That way you'll be notified of all the really fun videos we do in the future. I hope you guys have an absolutely wonderful afternoon, and thank you for your support.